AI never sleeps. Welcome back to the show. I'm your host, Ash Bennington, joined as always by Mikhail Voloshin. Mikhail, always great to be with you, man.
We are completely unprepared today, Ash. At least I am. So I'm looking forward to hearing what you got for me today.
There's no such thing, just extemporizing. Hey, listen, Mikhail, this is the first story I've got for you because it's so pervasive. The story is everywhere. My friends who are not in the AI space are talking about it. It's this $100 million bonus story that big AI shops are paying people $100 million to come and join them. I have no idea whether or not it's true, but as a meme, oh my God, it's an incredibly weird moment for the culture.
It's not actually true. There are no actual $100 million bonuses. That might be the total allocated budget for an entire department, but that doesn't represent what they've actually spent, nor does it represent a single paycheck or even a single bonus check for any given person.
Editing time, Mikhail here, and I might have to eat crow on that one. It appears that there is at least one case where it might actually be true. Now, I thought that it was false because it was an accusation that Sam Altman was making against Meta rather than anything that anybody at Meta had actually come out and said. And in fact, there were several people both at Meta and at OpenAI that said that Sam Altman's claims were exaggerated. However, there's at least one case of a 24-year-old entrepreneur from Seattle who has been offered allegedly $250 million to come work at Meta, apparently by Mark Zuckerberg himself, after originally rejecting a quote-unquote lowball offer of $125 million over 4 years. Now, it's not clear to me whether or not this $250 million offer is for this guy individually. His name is apparently Matt Dietke. He was formerly of Paul Allen's Artificial Intelligence Institute, where he developed a chatbot named Molmo, and he had since been starting up a venture of his own. I don't know if the offer is just for him or for his entire team, but either way, it certainly seems like at least in some cases, the numbers aren't actually all that exaggerated.
The
Exactly what I thought, and I was just waiting for you to throw that bucket of cold water on the myth.
But like any myth, there is an underlying grain of truth, which is that the Gini coefficient between the folks who know what they're doing in the AI space is getting much, much sharper. And the fact is that this is applying across all industries, and AI itself is exactly what's driving that. What I mean is, most of the folks that you're bringing to the show know what a Gini coefficient is, Ash. But what I mean is that the gap between how much you can do if you know a certain amount past a critical threshold is getting much, much greater compared to if you're below that threshold. Put in very layman terms, it's the gap between the haves and the have-nots, where what you have isn't necessarily money, but skill, expertise, or ability to use a particular tool set.
It's a general measure of inequality among a population. But let me ask you this, and obviously this precise number isn't what matters here. The bigger point, the bigger picture that you just pointed out so well there is this idea that there is a massive, and I do mean massive, like NBA salary level premium being paid to people who understand what they're doing in this space. And this is something that is a broader measure of what's happening right now in the market for these skills and the perception of how valuable they're going to be in the future.
Now, perception is exactly the right term, Ash. The fact is that these salaries, whether we're talking about the inflated or real numbers, either way, they are a bit of a bubble. The fact is that they're being paid based on what their employers believe that they're going to be able to do. And it's worth noting that a lot of this is driven by fear of competition. They don't know exactly what AI is capable of. They don't know what exactly they want for it to do for their business, but they do know that if they don't do something, their competitors are going to do it first.
Hey, editing time, Mikhail again. I had left out an important detail that I'd wanted to mention during the initial recording. which is to remind everyone that Meta is, after all, the same company that invested massive amounts of resources into the metaverse, banking heavily on NFTs and blockchain technology, which isn't dead exactly now, but certainly has not panned out with the kind of ROI that Meta was hoping on. Meta also put massive amounts of resources into the Oculus, and more recently into additional augmented reality glasses and other headsets. Now, my point here is not to laugh at Meta, but to remind folks that in the tech industry, the allocation of resources, including the capture of human resources, is often done preemptively with the understanding that potential ROI can come from those resources, not necessarily that there is a plan in place to manifest that ROI, nor necessarily guaranteeing that even if a plan existed that it would necessarily be successful. What I mean is that it's entirely possible for a company to spend hundreds of millions of dollars on people, billions of dollars on a project, and still have that project completely flop. Happens in Hollywood all the time. It happens in the tech industry more often than you might think.
Well, let me make it even more simple. What's fascinating to me about this is look, young investment bankers, young attorneys, they get paid extremely well. Young engineers in Silicon Valley get paid extremely well. This is orders of magnitude, not multipliers, orders of magnitude higher, one, two, three orders of magnitude higher than people in other extremely well compensated fields are getting paid right now. It's a shocking number to see in the headlines, and it implies that there's some perception, again, getting back to this word perception, there's some perception that there's going to be massive value creation generated by these individuals, meaning that they're going to have to grow businesses, again, orders of magnitude to compensate for those orders of magnitude increases in salary. Is it there? Where are they going with this, where they're going to be able to generate that kind of value?
But the question is not whether or not AI is going to grow their sectors by orders of magnitude, because it absolutely will. The question is whether or not the particular companies that hire these particular individuals are going to be the ones that are going to capitalize on that growth, and whether or not the hiring of these individuals is what's going to enable them to capitalize on that growth. Because
Right.
look, a lot of the folks that are getting hired are folks who are academics and researchers who have built the underlying substrates on which these LLMs operate. Most of the people that are hiring these world-class engineers, and I'm talking the Jan LeCuns of the world, I'm talking the Jeff Hintons, right? The gods of AI. And the question is, if you sell pizza online, do you know whether or not you're going to need a fundamental, like groundbreaking AI research? If you're Chuck E. Cheese's, for example, like you don't need to hire Jan LeCun to perform fundamental revolutions in neural network technology in order to sell Chuck E. Cheese online. What are these people getting paid what they're worth? Or more than they're worth? I can't say. I don't know what their actual bonuses and contracts really are in the real world. But what I can say is that a lot of these are being driven by the business sector's lack of ability to predict exactly just how impactful all of this technology is going to be. And Ash, this is something that you and I have talked about over the course of the last 2.5 years or so. This is one of the biggest evolutionary inventions that mankind has ever come up with, and it's going to take some time for people to understand what this even means. We can compare this to the printing press or the steam engine. I like to compare it to the invention of writing itself.
That's a pretty profound comparison. But what's interesting to me is that the perception when you're paying these kinds of numbers, these aren't theoretical things. These aren't like the perception. Again, the perception is, oh, this is going to change the world by 2057. This is going to change the world pretty quickly, and we're paying the money now, like today.
Yeah, I think that people are unprepared for just how fast things are moving in the world of AI right now. In 3 years, people have gone from like GPT as a chatbot, what's this good for, to we've replaced our entire marketing, HR, and mergers and acquisitions departments, and they're now being run by AI. And so that's just what we know we can do already. We're not even talking about what it means when the AIs are entirely running the business itself.
Talking about things that are down to earth that are happening right now today. Since our last show, I recently started playing around with Grok 4. I'm not sure if you've had an opportunity to play with this, but I was pretty impressed by two things about it. The first was the scale of the output that it could generate. It could generate huge amounts of output. And the second was the native sophistication with which it addressed me. Very intensely scientific and mathematical language, really interesting stuff. It seems to me that there may be something new in Grok 4 in the way that it's processing, the way it's interacting, and the output. There's something about it that feels new. I can't quite put my finger on it yet. I haven't spent that much time playing around with it, but there is a sense that this is something just a little bit different than what's come before.
So we can talk to a certain extent about whether or not it has more powerful agentic tools that it's calling under the hood, or whether or not it's got self-checking mechanisms that might be more performant than GPT. But at the end of the day, I think that the key differentiator is that Grok was trained and then fine-tuned with less stupidness is the best way of putting it. Look, we've talked about this before, which is that
what's the technical definition of stupidness in this context?
if you it's very difficult to train a neural network, and I don't just mean an artificial one, but a human being as well, to be able to operate in both high IQ and low IQ modalities at the same time. In other words, it's impossible for dumb people to smart themselves up, but it's also very difficult for smart people to dumb themselves down. It can be done, but at the cost of additional CPU cycles, so to speak. So the analogy that I often use is that if you have two neural networks, one is only trained on orbital mechanics, the other is trained on orbital mechanics and astrology. Which one do you trust more to correctly calculate an insertion orbit to Mars? The idea is that the astrology knowledge will interfere with the actual Newtonian calculations and will end up making the dual purpose neural network emit incorrect answers more often than the single purpose one.
But what if you launch when Mars is in my seventh house?
This is the dawning of the age of Aquarius. Now, look, I use astrology as a sort of a silly fallback, but the point is that, with GPT, you might encounter this scenario every now and then where here's a real world example that comes up all the time, at least in my usage of GPT, where I'm asking it a real problem or a real question in quantum mechanics, for example, in which I really want it to produce a certain answer because I want a certain answer to be true. But in this particular case, like, I'm experimenting with some FTL comms systems, which by all rights should be impossible. I keep looking for a loophole in QM that might facilitate such things. No such loophole exists, but hope springs eternal. So I'm talking to GPT. It's cranking out some accurate mathematics describing the evolution of certain quantum systems, and I ask it to anticipate a certain FTL phenomenon. And upon asking it to do so, if I do it enough, it switches into a sort of different communication modality, and it does it very subtly. But suddenly, it's talking to me like a speculative writer of science fiction rather than an actual physics professor. And when it does so, it starts talking about making things happen in a fictitious scenario that I'm writing for a book rather than for an actual experiment in a physics lab that I want to set up as a graduate student.
And do you tell it that? Do you say, hey, listen, go ahead.
No, it's just that it has multiple communication modalities. Look, it's been trained in all of human literature, and so that means that, like, it's been trained on Bose and Heisenberg and Bell, but it's also been trained on Larry Niven and H.G. Wells and Arthur C. Clarke. So what that means is that as I'm communicating with it, it's drawing on all of its knowledge to provide to me the response that would fit the next word that it should communicate to me during in the context of its conversation with me.
It's interesting. You mentioned something that's actually come up on one of your posts on social media that I've been thinking about, which is that ChatGPT and all the other LLMs out there that we interact with are simply glorified text prediction engines, which is a hard thing to get your head around because you can understand that. You can understand that it's literally just searching for the next letter, the next word, but it's really hard to reconcile that when it's giving you answers that are not only just intelligent, but seem applicable to real problems, indeed are applicable to real problems. And the shift between science and science fiction, between quantum mechanics and quantum mechanics science fiction novels.
Because to answer your question about what is it about Grok that that might be different from GPT, there may be a lot of things. I'm not sure under the hood exactly all of the things that went into Grok 4. But the key point that I'm trying to drive home is that a difference in shift of emphasis in the training data accounts for a dramatic difference in performance. If it was trained primarily on engineering texts, and if it was also trained on corpora of texts in which professors are basically telling students stuff like, no, really, that doesn't happen, or that can't happen, then it's less likely to slip into a modality of where GPT would say, oh, but what if it could? So the point is, Ash, in your experience with Grok, you mentioned that it talks to you in a more scientific, more mature, more like rigorous manner. And to me, what that sounds like is you're hearing what happens when an AI has been taught what to say when a person just is clearly trying to move the AI into a direction in which it's trying to emit falsehood. Instead of the groveling, sycophantic yes man of GPT, Grok is more capable of saying, no, dude, no.
It's interesting that you should say that because I was interacting with GPT earlier today and I asked it a question and I clearly gave the implication that there was a thing that I felt negatively about. And I asked it to characterize the thing and it gave me all these negative characteristics. And then I later asked it, hey, is this a true reflection of the general view of that thing? Or is it colored by the fact that I asked you a negative question? And rather to my surprise, it said, actually, yes, it was colored by your initial frame. Would you like me to do this again from a more objective perspective? I said, yes. It essentially refactored it and created a more objective account of the thing I was asking for.
No, it didn't, Ash. What it did was, by virtue of you asking it, hey, are you just yes-manning me, or is this an objective view? What you did was you got it to you got it to slip into a communication modality where it realized that it would please you more by telling you that actually no, it was being sycophantic, and then reevaluates from a quote unquote objective perspective. So
well, what it always does, I guess we could argue, is it just predicted the next word based on what it thought I wanted. But what's interesting to me was it didn't just apologize for the sycophancy. It actually created a new answer that was objectively more objective.
Yes, but that answer is exactly what it needed to produce in order to please you. It is what you asked for. It is still giving you what you asked for.
Yeah. Wow, that's a sophomore year in college dorm room head scratcher.
Yeah, that's very much of a cognitive, introspective, pot smoking thing. But you know what? These abstract philosophy questions, or like state of mind questions, start to become relevant when computers have not minds of their own, but certainly the simulacra thereof.
Thou shalt not make a machine in the likeness of a human mind.
Yeah, boy, that's an interesting way to talk about it. Mikhail, what have you noticed these last couple of weeks since we've done one of these shows? What's been on your radar? What stories have jumped out at you as being especially interesting or frightening?
There's as I'm sure you've noticed, there's been a lot of buzz in exposing agentic AI, specifically in the context of coding environments and software development tools, to the general public. And this is a significant set of story developments because that's my job. But we've seen just a few days ago, GitHub Copilot's team exposed something called Spark, GitHub Spark, that is still very much a tool for developers, but it's a tool that allows for you to create entire applications from soup to nuts.
I sent you one of these a couple of days ago, these AI IDEs that purport to basically say, hey, oh yeah, just tell us what you want and we'll build it for you. How far away, and I know you did some testing on this, which I thought was interesting, and you shared the results with me. How far away are we from really being able to do that? Or maybe the more germane question is, where are we right now in terms of the relationship of the claim to the actuality?
The easy answer is I would estimate about 2 to 3 years. The more complicated answer is the definition of app is going to change under our noses as we expose these capabilities of build your own apps, so to speak, to the general public.
What's that mean? How's the definition going to shift? How's the reality going to shift?
Everybody who uses digital devices nowadays takes the concept of an app for granted. But the fact is that an app in and of itself is a relatively new thing in technology land, so to speak. We didn't have apps per se before the App Store, which debuted around what, like 2006, 2007, something like that. The term app was marketing speak for programs and office suites and stuff like that that you would install on your devices. Because remember, in the in the bad old days, before everything was always online and before the cell phones had serious computing power, we installed programs. We would go to Babbage's or sometimes Radio Shack, and there would be a wall of boxes that had discs, and we would buy those discs as physical objects, and we would put them in our disk drives in our computers at home and install the software, install the program onto our hard drives, or sometimes just run the program directly off of the disk. In the last 30 years, the concept of how we run, less than like 25 years, the concept of how we interact with software on our devices has fundamentally changed. It's not like we download it from the cloud, we install it on our devices, our data is stored in the cloud, and it's tied to our account and so on. So the relationship between how we use these machines and the modularization model that we use is going to be very different in the next several years. And the fact that like commoners can create what is called an app now is going to be part of what changes that paradigm.
I'm sure people in their 20s are wondering what Babbage's was, but I can see the sad look on your face for those listening on audio. But it's a really interesting point, right? Which is that this idea of what we've come to think of as apps, relatively recent phenomenon. I think it was after 2007. I think the App Store came a couple of years after Jobs launched the iPhone. So it's been probably closer to 20 years than 25, relatively short period of time. So to your point, why might that not change again in a completely radical way, in a way that we don't perceive right now?
Exactly. It's kind of funny because you can look to science fiction again for models of how people might interact with computers in the future. One of the things that always struck me when watching Star Trek Next Generation as a kid was that the crew of the Enterprise never they were never caught like programming. They didn't have like development studios. They never, and the concept of a program didn't really exist outside of like the holodeck or something where it meant something very different. It was when they ran a program in the holodeck, it wasn't an execution of instructions. It was more like the way that TV shows use the term program. And now we return you to our regularly scheduled programming.
Mm.
The fact is that their computers didn't have or didn't will not. I don't even know how you use proper future versus past tense when you're talking about a show that was made in the 1980s and takes place in the 23rd century. But the point is that the crew of the Starship Enterprise didn't interact with their computer in the form of like discrete apps or discrete programs or discrete pieces of computing like modularity. Their interactions were more along the lines of, computer, I want you to do a thing, and it just does it.
Hey, and by the way, to harken back to that period, I remember there were a lot of usability purists who hated the idea of apps. Everything should run in a browser, was the argument from the usage gurus of the time.
Nowadays, everything does run in the browser. Like, in fact, the only thing that people really install on their desktops anymore are games. sometimes office suites. But the fact is that there are many people who get away with owning a computer that doesn't even have any programs on it other than the browser. That's the whole concept of the Chromebook.
Chromebooks.
Yeah.
Yeah, exactly. Mikhail, you thought we didn't have a lot to say. This has been an unusually long episode, I think.
I guess so. I feel like there's probably one or two more points that we should cover before we close it out.
What else is on your mind?
The process of writing software with AI, and not just using AI to write code, but to integrate the AI into the code. It's one thing to say, hey, I want to write an application that'll read my email, that lists my email messages, for example. I don't know why you'd want to do that, but go with it as an example, right? Maybe you want to color code your email messages. There you go. So you can ask an AI to do that, and it'll work with you interactively until you've hammered that application out. I'm talking about something different. I'm talking about having an application that calls AI, says, I want go through each and every one of these emails and do something to it. Either summarize it or reply to it or consolidate it into a report or something like that. These are different use cases. Basically, in one case, AI is above, and in the other, AI is below the more conventional code block. Having the AI write the code versus having the code call an AI. Does that make sense to you?
Yeah, it does. So essentially, you're talking about in the first case, you're telling AI to generate code to create a more traditional program or application. In the second case, you have an application that essentially sends stuff over to AI and says, hey, process this, or pull stuff in, or else go grab data and do something to it.
Exactly. So, and by the way, my job more involves the latter than the former. So I'm not completely threatened by these AI code generator apps just yet, but we'll see what the landscape looks like in 2 or 3 years. My point is, Ash, that we're going to see a lot of people slowly coming around to the understanding that AI by itself cannot be used as an execution engine, that traditional code needs to exist. Now, it doesn't necessarily need to be written by me. No, I'm not saying that in order to protect my job. What I'm saying that, the reason I'm saying that is as a warning to folks that are trying to throw AI at a problem and finding that it's just not delivering. They're finding that the AI is going through the motion of executing an iterative task and then stopping, or like pretending that it performed the iterative task and then just giving them an answer that it would have produced, quote unquote. So my point is that in the computing paradigm of the future, it's not going to be all AI or all traditional code. AI and more traditional coding systems will integrate with one another and will need to live in a not just side by side but intertwined manner. AI needs to be able to call out to iterative systems, like it needs to have a Python execution environment that it can write code to and that it can then run, and that execution environment needs to also be able to call out to AI agents to perform tasks that traditional code can't. So we're going to see more and more that that code of AI above the code and AI below the code is going to become a more interwoven thing.
Really interesting. And do you think that there are any ways right now that you're seeing for this enhancement or the ability of AI to interact with different subsystems to do some of the things that it's not good at? I think that's the implication of the Python environment, where it could actually create structured code and have it execute that code to do things that maybe it wasn't good at, but it needs to have the self-knowledge, I guess, if we can use such a weird word for AI, to understand that it's not especially well suited for a task.
So that's exactly right. And in fact, it's actually quite easy to train these AIs or even prompt them, not outright train, to know what tasks they're good at and what tasks they're bad at. In other words, if you have a large prompt saying, you are good at coding Python, but you are bad at solving NP-complete problems, for example, then as it's talking, as it's emitting tokens, it can just by having that text in the prompt, it will start emitting tokens that are in line with solving an NP-complete problem, and then it'll interrupt itself and be like, but you know what? I'm not good at this. I can, however, write a program that will solve it for me. And by the way, this is not some kind of shocking bootstrap mechanism. It seems like it's a shocking bootstrap mechanism, but human beings invented computers for a reason. I can't solve an NP-complete problem as fast as one of my programs can. Look, the entire reason we invented Turing-complete machines, why we built the very first one, ENIAC, was to crank out artillery table ballistic trajectory calculation for World War II, where prior to ENIAC we had rooms and rooms of human computers. It was literally a job, a person who computes. You are a computer, which were usually women who were not drafted. So all the men were away fighting. So the pool of computers was almost entirely women. And they were trained in math. They were very good at calculus and whatnot. And they were literally tasked with just solving calculus equations all day long. And the reason we built the first computer, was the first electronic computer, was to automate that process. My point is that just like I can write a program that does an iterative task better than I myself can write that task, an LLM can likewise write a block of Python code that can do a thing that that LLM by itself cannot. Now, I've long said that an LLM by itself is not the path to AGI. People are asking, like, oh, are we at AGI? Are we still far from AGI? And it's a loaded question because LLMs will not and cannot be AGI systems in and of themselves. But an LLM can be the dispatch module for a combined cohort of systems that together can be considered AGI. And the ability of an LLM to write a program that bootstraps its own abilities that then get outsourced to this Python execution environment is one manner in which that happens. Other manners in which that happen, for example, are the ability to access a ground truth memory module, the ability to for example, outsource to a spatial reasoning module, both two-dimensional and three-dimensional, the ability to outsource to modules that, for example, are better at logical reasoning. That's one of the things that Grok 4 does under the hood, as far as I know, is that it has an LLM that's able to take a problem and formulate it into a set of logic symbols, and then it outsources those logic symbols to a logical inference engine, or a logical deduction engine rather, and then that deduction engine can solve, it's a theorem solver, and so it can come up with truths within the context of those axiomatic of those axioms that were laid forth to it. That's something that an LLM is bad at, but a theorem solver is good at, and so the LLM can just send that to a theorem solver and come out with solutions, thus gaining the ability to be a combined system, to be a system that has the ability to reason in a more rigorous manner than the LLM by itself.
What a strange and complex world.
It's not that different from the way the human brain works, by the way. Our prefrontal lobes are probably the equivalent of a dispatch system. We've got spatial reasoning both in our parietal cortices and in our occipital lobes. What we're going to see is, from a customer standpoint, from a end user consumer standpoint, I don't know if you're going to see organizations like Anthropic or X or OpenAI advertise stuff like, oh, we've just attached a spatial reasoning module and a logical inference engine to our LLM product, because the consumer public doesn't know what that means and wouldn't be able to appreciate it. What you will see,
but they write white papers.
they do. Yeah, I'll be able to see it. I'm just saying you're not going to necessarily see headlines about it.
Gotcha.
What you will see is that you'll see announcements like Grok 4 is much better at reasoning. And something like Grok 5 is better at solving three-dimensional spatial problems, that kind of thing.
Yeah, when you say it's really not that different from a human brain, humans possess human brains, but we've never created anything near that complexity before. And we also have never created, and this is, I think, one of Elon Musk's focuses, is that creating things that scale with computing power. So that essentially, if you build this system and as time goes by, the computing power, everyone knows about Moore's law. I was watching this show. It just keeps getting significantly, exponentially faster over time.
Yeah, can you talk about that little find that you made, Ash? You forwarded this to me a little while ago. Why don't you talk about it for a second?
Oh gosh, I don't remember it really that well, but it was a headline about the way that Elon Musk had, I believe, at Tesla stated that he wanted AI to work, which was he wanted to make sure that as the computing power scaled, that the capacity for scaling intelligence would scale as a factor of it rather than with diminishing return. The idea here being that he wanted to build these core architectures in a way that as computing power increased, the power and complexity of the use cases that the AI would be able to address would increase with it.
He did it in a very interesting way. What the Grok folks realized was that you get much better scaling performance if you build an AI that's able to reach conclusions on its own rather than have those conclusions fine-tuned or trained within the context of its of its training set or data set. In particular, for example, I forget the exact example that he used, but it's something like you can train the AI on the fact that the Earth is round, for example. Or you can give the AI like information like what happens to observable stars as you travel south and north, or what happens to ships as they sail over the horizon, or certain patterns of celestial motions and whatnot. And then if you ask the AI, what shape is the Earth, it'll think about it for a little bit and say, oh, wait, it's round, isn't it? So they found that when you take that approach, it's able to reach, it's able, like, though it starts at a lower level than humans, it's able to reach higher levels, but because it's given the ability to iterate on its own achieved knowledge.
Very interesting. Mikhail, what a fantastically interesting conversation, as these always are. I wanted to give you the opportunity. Final thoughts, key takeaways, a lot of conversation here about a lot of different topics for our audience. What would you like to leave them with from this conversation?
That's a really great question. I saw someone on Facebook lamenting in terror, honestly, about what the advent of AI and the spread of AI to every sector of the economy means in the long run. Now, this person is a little bit older. They're very much a traditionalist, and they're very much not a technologist. But they were going through the existential dread that a lot of people either have already been hit with or will be hit with in the very near future about basically this guy was asking online like what's even the point of people right now? If it's going to replace every job, if it's going to dominate the arts, maybe it can't do better than the best artists, but in like it's like achieve parity with the median, right? This person was like, are we just going to be like relegated to working the robot factories? No, we're not, obviously, because
Because the robots will work the robot factories.
right. So it's like, what's even the point of billions of people even being alive? And this guy was just like, why did we create this thing? Can we stop? And no, we're not going to stop. Like the genie's out of the bottle. The question has never had an answer. Like, this is not a question that's been unique to AI. The question of what is even the point of us is something that man has been asking ourselves since we developed the ability to speak, possibly even long before that. So that's something that's going to come front and center because the things that we've used to distract ourselves from asking that question, gotta till the field, gotta grow your food, gotta hunt that bison, gotta smith that metal, gotta drill that machine,
Gotta write that code.
Gotta do my day job, gotta pay my rent. As AI removes all of that from us, then that question becomes front and center again, and you gotta start asking yourselves, why is anything, and why am I here? Why are any of us here? What are we even doing? And yeah, that's the billions of people being hit with that question all at once is gonna be interesting. So get asking that of yourself sooner rather than later.
Because the answer will be, I do what my robot overlords tell me to. Mikhail Voloshin, always a pleasure to get to do this with you, man.
Until next time, Ash.
Until then, AI never sleeps.